right. Hi, everyone. Hello, Moss. So we're going to try to have the Discord window running during lecture. I'll see whether it works or not. It might be too large a class to manage. I encourage you to interact with people on Discord to the extent that it doesn't actually interfere with your learning. I don't know if I trust you to do that, but give it a shot. But yeah, like if you answer questions, yes, nice turtle. Okay. So let's give it a shot. So the Discord invite was on Piazza. So you should have signed up on Piazza. If you have, then you can then ask questions about the lecture on Discord. Actually, I'll make a new channel for that. Okay, so I'll rename it while people are coming in. What's going on here? So, okay, all right, so that'll possibly load, and when it does, then you would be able to ask questions. So in the meantime, I want to talk a little bit more about the course in general. So we saw kind of small examples of what the Python programming language looks like. So I just want to talk about the big picture of what programming languages actually are. So a computer program, like we said, is a sequence of instructions to the computer. So for example, here's a sequence of instructions to the computer, right? So it says print oops. So I was late to the lecture before that, so that's why it wasn't funny then either. Here we have the instruction of compute 42 plus 1 and then put it in A. And then we have the instruction of printing A. So if you run this Python program, the output would be oops without the quotes, because print oops is just print OOPS, not the quotes. And then this is an internal thing inside of Python. Nothing gets printed because of it. And then print A means print whatever is the value that's stored in A, so that would be 43. Right? So that would print oops, and then it would print 43. Now, this looks simple. It's actually extremely complicated, right? Because if you think about what it means to execute the instruction print oops, well, the screen on which this is printed consists of pixels, right? So print oops means in a particular location, light up the particular pixels so that the pixels together would make the word oops. But not in any random way, in a particular way. What kind of way? Well, whatever the user's like also overall preference. So some people install special software, for example, to not have the blue pixels shine in the evening, because that supposedly helps people fall asleep better, stuff like that. I don't know if it works, but give it a shot. So while you still can, in principle, go to sleep at night. It's actually quite complicated. It's not about just like put an O, put a P, put the S there. You need to look up the font size, look up where actually you need to display it. You're displaying it in the window. The window can move around, right? So it's not actually a simple thing. You could imagine something very simple. In fact, people in the very beginning, people imagined a typewriter where print oops would be like literally as simple as pressing down on the key that says O, and that just transferred the stencil for O on the paper, right? So that you could imagine, you could probably make something like that. If you have a typewriter, all you need is like a mechanism to figure out which key to press. And in fact, like that's the first kinds of printers, that's what they did, right? But here it's very complicated. So way below the level of this kind of program, which is what most people do, it must be that somehow the electronics of the computer actually make everything work. How does that happen? Well, the full story is like you take the computing courses in the first 2 years of EngSci, and then you can specialize in ECE, and like by the end of 4th year they'll tell you, and then you can go to grad school or something, and then maybe you get to actually understand it as well. But at the basic level, what's happening in the hardware? Well, on the chip, you probably all know there's ones and zeros. So what does it mean that there are ones and zeros on the chip? It means that in a certain area, if it's low voltage, it means 0. If it's high voltage, it means 1. And then there's lots of locations with low voltages and high voltages, and you have this kind of pattern of low voltage, high voltage, and so on. So that's the pattern of zeros and ones. And then machine instructions are kind of like this. So kind of like saying A is equal to 42 plus 1, in the sense that it's saying, look at those patterns of voltages, and then maybe add them up, so kind of superimpose them, something like that. And then transfer those voltages. It's possible to do. You'll learn how later on. Transfers those voltages to other locations. Maybe some of those voltages make it so that one pixel on the screen lights up in a certain way, right? So a lot of those kinds of machine instructions basically correspond to just one instruction over here, like something like print oops, right? And then the CPU, the central processing unit, is a part of the computer that's responsible for executing those kind of machine code instructions. So that's what's happening kind of at the physics level, like actually. So it's very complicated. It's a lot of simple rules that interact with each other to make up for complex behavior. We're not going to get into it in this course. In this course, we're just going to say, well, we just write those instructions, and then Python just runs it for us. So Python, so that's the language in which this code is written, for example, is a more human-like language. So what it means is that the instructions are not like make this voltage high, make that voltage low. The instructions are more like put this text on the screen or something. So that's what's referred to as a high-level programming language. This is as opposed to a low-level programming language, which is closer to actually manipulating the voltages. So separately from being a language, Python is also software. So that's also known as the Python interpreter. So the Python interpreter is what's running in the right-hand side pane inside Paizo. So this is a program, in this case Python version 3.7.13, I guess, that's running on my computer and is displaying inside Paizo. So the Python interpreter's job is to read code like this, print oops, a equals 42.1, and then just follow along and execute whatever the instructions here. So underneath it all is low voltages and high voltages in like millions and millions and millions of them interacting between themselves that make it be the result that oops gets printed on the screen. We don't think about it starting from this point on in this course. But basically Python is just taking this kind of text and just executing it. Whatever it says, it does. So that's Python. Now Paizo so this is a Paizo window. It doesn't actually say Paizo anymore. It's interactive editor for Python. So that's what's called an integrated development environment. And that's just software that enables you to write code in it and then to run that code. So Paizo is separate from Python. Paizo runs Python inside it, and then you can also tell Paizo, here's a program, run the Python interpreter on the program. The reason we're using Piezo, you'll see a little bit of it today, is that it allows you to very easily, any IDE allows that, but it's a question of how easy or not, and also a question of taste. So Piezo allows you to very easily execute programs line by line. That's not necessarily the case for other IDEs, so you'll see what I'm talking about in, I don't know, half an hour. So an interesting thing to note is that Piezo itself is actually written in Python, and you can modify the code for Piezo and it'll behave differently. So on your computer, if you go to help about Piezo, it'll tell you where it is that the Piezo that you are running lives on your computer, and this is just a bunch of Python code. You can actually go and modify it. So here I have like an uninteresting part of Piezo, so that's code that just starts Piezo, but that's there. Okay, and in fact, kind of, it's not that difficult, depending on what you do, to modify Piezo's behavior if that's what you would like to do. So Piezo is open source, and it's written entirely in Python, which means like you can just go and so one thing that they've done, they have since fixed it in a better way, but it used to be that it didn't like match the parentheses here when you close the parentheses. So for example, I wrote that, stuff like that. If you just want to do something fun, you can do something fun as well, depending on your definition of fun. So, okay. That was probably a little bit abstract. That is fine. So obviously, I'm not going to like test you on stuff that they said right now. Starting now, you're going to be tested on everything. But you know, like sometimes people just say like, oh, like you didn't like define all your terms, and sometimes you can't really define all your terms, but in this case it was just 15 minutes, and now you can say it and tell you what everything is, even though part of it was just saying, well, it's really complicated, you need to take a few years to understand it. People ask me, and you know, I'll give you my opinion about how to succeed in this course. I'm not saying that I'm 100% right. I think I'm probably more right about it than most people, but obviously there's always alternative strategies. That said, don't like go off on your own unless you're like really sure that you're right and I'm wrong about how to succeed in this course, because after all, I write the exam and I grade it. So basically, ESC180 is about solving problems using programming. It's not really about Python. Now, there's going to be, in fairness, like 2 or 3 weeks where we really focus on, okay, like those are the exact rules for how Python works. This is for situations where the rules are really quite complicated and there is something to be done there for a couple of weeks. But most of it is kind of like this. It's like, well, like you take the right-hand side, like 42 plus 1, and you put it in A. I think everyone by this point knows this, right? And most rules are like this, and there's not very many of them. So I would make the analogy to something like high school math, which all of you are familiar with, where it wasn't really about learning the rules, right? So it's not like learning, okay, like A times B plus C is A times B plus A times C. Well, yes, it's a rule and you need to learn it, but it's not really complicated. The complicated part is really applying the different concepts together, figuring out how to get from here to there by figuring out which of the concepts apply, by looking at the problem. So traditionally for most people, most of the time, like word problems in math are considered to be like the most challenging thing. So it's not really about even the rules, it's more about kind of looking at the description that's external to math and making the math fit that description in such a way that you can then use math to get some kind of answer. And it's the same here, right? It's not about, not to say that you shouldn't pay attention to the rules, but it's not really about that most of the time. Most of the time it's about problem solving. And that means that what I do in lecture now is like not that useful, to be honest. Any textbook is not that useful. I mean, I think it's necessary, but it's not, because otherwise things won't work. But it's not it's not the thing that makes you succeed. The thing that makes you succeed is writing code. So that's why we have a 3-hour lab in addition to 3-hour lecture in this course. And really, I think probably more learning is happening in the lab than in lecture. It's just that the lecture is also kind of necessary, because otherwise you come into the lab and you don't know where to start. But really, the learning happens by practicing. So one thing I would suggest is, like, obviously don't rely on being able to like just read the textbook the night before. It's just not going to teach you anything. You also can't really teach people, like the textbook, if there were a secret about how to do problem solving, I would tell you. It's just that there isn't. So a lot of it is gaining the right intuition, gaining kind of a mechanical almost skill in the same way, like I mentioned, that like playing an instrument or riding a bike or something, you're gaining something that's very analogous to a mechanical skill as you're practicing problem solving. So that's not to say that you cannot at all cognitively improve. There's various strategies that we'll discuss for problem solving, and also kind of just on your own, you can say, for any example in lecture where you would say, okay, I now see the solution and I can now kind of see that it's right, but I would not have come up with it. Or in the lab, like there's a difficult problem and you didn't solve it, maybe you tried, but maybe a little bit, but not completely. So what I would suggest every time that you encounter something like that is you just make a mental note of it and say, okay, like I didn't solve it this time, so what was I missing that would enable me to solve it? And sometimes it's kind of a particular idea, a particular style of solving a problem. Sometimes the answer would be, well, it's just that it's a problem that's really analogous to an example from lecture, and I didn't remember the example from lecture. And sometimes it's something in between. So I try at least as much as possible to not make it that I show people weird examples in lecture and then you have to memorize my weird examples in order to solve the exams. Of course, different people will have different judgments about what's weird and what's not, but you try to kind of show the important, interesting things in lecture. Sometimes the interesting things are not important, sometimes the important things are not interesting, but as much as possible, I try to be general. So if I show it in lecture, unless I specifically say this is a silly example that I just think is funny, it's probably important. But even the funny examples, you should probably remember at least understand there's limited value to like memorizing every example in lecture. So I see sometimes people attempt this kind of strategy, and some people really have like this photographic memory that I can't even imagine to understand, and they maybe came to rely on it, and what happens is like they like literally memorize everything from lecture, and then the questions on the exam are like a little bit similar, but like not so similar that you could just copy and paste, and then they still struggle. That's not to say that having photographic memory is better than not having photographic memory, but it's not super useful. I would say what is useful for every example is write it down, say, okay, like either I understand it and I can move on, or I don't understand it, I wouldn't have been able to come up with it, so I need to understand, okay, like what's the idea there that would enable me, if I knew that idea, to just reproduce the entire solution. So that's kind of that as far as success in the course. We'll obviously talk more about it later on as well. So, okay, I want to go back to the actual content. So, actually, let me check what people are saying on Discord, if anything. Hello. Fascinating. Okay. I think that person is actually not in the class. I don't know what they're doing there. But either way, hello. Okay. I'm busy. Okay, all right. So last time we had conditionals. Let me switch to this. So the conditionals, if you remember, worked like this, right? So this is not Python. This is just kind of something that resembles Python. So I'm saying the way you build a conditional block is if, then you have a condition, so something that can be either true or false, then you have a colon, then you have an indented block, and then you can have, if you want, an else, and here you have a block as well. So for example, so let's do, okay, like cutoff. This is going to be the Waterloo, well, not Waterloo, York cutoff, okay. What is the York cutoff these days? Probably 78. So you can say, I'll have a grade, average, I guess. And let's say I have a 96. And then I'll say if the average is greater or equal than your cutoff, you got into York. Okay. I don't know. Something I heard once. And then so if it's lower, there's always TMU, whatever, something like that. So I actually think TMU is might be the other way, but anyway. So what's going on here? So this is going to get executed if, don't post it on social media. So I suppose I am posting it on YouTube, but that's right. So if the average is greater than that, then this gets executed. So here, note that this is a little bit different for what we saw before because there's two print statements there. They're both in the block, so they both are going to get executed. So if I run it, okay. So here there's always TMU. So if we make the average be 75, then what's going to happen is this gonna get executed. Okay. So now here I can write something new. So I can say, for example, okay, something like this. So note that this is going to get executed regardless, right? So this is separate from this, and that's not because there is a space here that didn't have to be a space here. It's because this is not part of the block that's underneath the else. So regardless of what the grade is, so whether it's 75, that's going to be, there's always TMU, or it's 85, and then this block, this gets printed and this gets printed. This gets printed regardless. So I could make it part of the else block. So here, what you do is you just press the tab button in Paizo. So tab is the upper left corner. And now this is part of the block. So that means that that's only going to get executed if you go inside the else. So here you got into your, okay, the fork thing, and then here this is only going to happen if I make the average be like 75. Please mute me. Okay, so I want to show you what's called tracing. So this is just going to be going through the program step by step. So what I had done is I pressed stop, and now I'll do Anaconda again. So the reason I did that is because I wanted to reset my workspace. So the workspace is where the variables that are currently active are being displayed. So I can, for example, say a is equal to 5. And now here, now you'll see a is 5. It wasn't there before. So what I'll do is I'll put what's called a breakpoint here. So this is clicking on the gray bar over here with the left button of the mouse so that there's a red dot. And now I'm going to run it. So to run it, I can press Control E, Command E on the Mac. So all the keyboard shortcuts are over here. So Control E is execute file. Yes.
How do I get the workspace to?
Tools, workspace. So, okay. So I'm pressing Control E, or I could say run execute file. And now I'm over here. So the green thing here means that I'm about to execute your cutoff is equal to 78. So now that I've done it, I can look it up, and here it appeared. So your cutoff is 78. Average is not yet here. So if I press this button, so this is this one, debug next. That's the one that I'm using currently. Then now average has appeared, and now average is 75. At this point, I'm saying if average is greater or equal than your cutoff. So what's about to happen is Python is about to decide whether this is true or not. And then depending on whether this is true or not, it's either going to go here or it's going to go here. Make sense? So in this case, what is it going to be? Well, I can look it up. Average is 75 over here. So it also says average 75 over here, and you can infer that it's 75 now. Of course, there's various things could be happening in between. In this case, not. So I can highlight this and press Alt-Enter. I could also just copy and paste it manually. So I did like Control-C, Control-V. And that way I know that it will be false. So when I'm debugging, so debugging refers to trying to fix the program, that can be very useful. You know that you'll either jump there or here, and you want to know ahead of time whether you're going to jump here or there. So here I checked. So that's false. So since it's false, that means that we're going to jump to 8. So, and that's indeed what happened. So now I'm at 8. And now we printed this. And one annoying thing about Paizo, it honestly is more convenient than other IDEs in my opinion for stuff like this. But one annoying thing is if it's the last line, it's really in your interest to press this button rather than this button, because this button sometimes leads to trouble. So now we're there. So to emphasize the point, so if I made this be outside the else block, then if I run it again, so here it's like this, and then this gets printed, and then separately we go to Go School, and that gets printed like this. If the average were 87, then what's going to happen is we do line 5 and line 6. So, and then after line 6, what's going to happen is we're going to jump to line 10, right? Because you either go inside the if block or the else block. You're already in the if block. So once we're done with the if block, it's going to be to line 10, the next thing after the if else. And you can see it here, that here we are. And now we'll print Go School. So, okay. Questions about this? All right. Yeah. Well, I mean, depends on what way. Well, you don't have a break. So, put a break. All right. Yeah. Sorry, speak up, please. Sorry, I didn't hear anything. Yeah. Speak up, please. No, just up. The microphone, that's going to be complicated. Yeah.
How did you start the debugging phase?
So I just put a breakpoint and then I run it, right? So here I have a breakpoint and now Control E, so execute file, and now it's debugging. So and it ran until the red point, and now we're going line by line. In principle, you could put this anywhere, so you could put this, like for example, over here. So I'll stop. So here what happened is I never got to this point because the average was actually higher than the cutoff, so I'll make it like 67. And if I run it now we're about to do line 8. All right. So for now, so this just means stop everything. This button, fair warning, doesn't always work. So in general, you would be going just next for now. You could also press continue. So continue just means continue running, stop doing things line by line, and just go to the end. So that will just run everything. So this is next, go to next line. And this is continue, so just continue running, stop doing line by line. Yeah?
What about the two contenders?
Sorry, speak up, please.
What about the two in the middle? What do they do?
The two in the middle?
Between the next line and the...
Sorry, I don't really understand.
Like the two buttons between...
Oh, I see. So that's about when we start working with functions. So this is step into the function, step out of the function. Okay. Yeah.
How did you get the Anacon 37?
Well, so I'll actually mention, so this is actually related to the physics lab in a way, so I'll mention it separately once I'm done with this lecture, okay? So I think I'll have some time. But basically it's, so you can have kind of various versions of Python running separately, and you can choose like that. So okay. All right. What's happening on Discord? Fascinating. Well, you can't see anything here. Oh, okay. I see. Okay. All right. All right. Well, I mean, yeah. This is fun so far, so that's fine. So okay, just behave yourselves. So let's do something slightly more complicated. So you can have kind of more complicated conditionals. So basically you could have an if, and then an elif, another elif, and then if you want an else at the end. So elif stands for else if. So the way it works, if you remember, if else was just check if this condition is true. If it's true, then do block 1. If it's not true, then do whatever is under the else. With the elifs, it's check this condition, and if this condition is true, do block 1, and you're done. If this condition is not true, then check condition 2. If condition 2 is true, do block 2. If it's not true, continue checking condition 3, and so on. All right? So let's write something like this. 36. And we'll do something like this. I'll do like if exam grade is greater or equal than 98, something like this. And if it's equal to 98, something like this. So set face, okay? So something like this. So this is a slightly useful program, right? That's like displaying, automating your emotions. That's great. You don't need to think about it. So basically what we're saying is like if the exam grade is greater or equal to 98, then we print hooray. If it's exactly 98, then we'll print this. And then if it's greater than 80, we'll print this. And then if not, we'll print the sad face. And then regardless of anything, we'll say at least, okay. So, yeah.
If the grade is exactly 98, wouldn't it not just print grade off the next?
Yes, it would. That's a good point. We'll get to that. And in fact, I'm not going to pretend that was on purpose, but that's actually good. Okay. So let's try to run it. So here what's happening is you have happy face, and happy face is because it's greater or equal than 80. And then regardless of anything, this gets printed because this is not inside the else, this is not inside of any of the elifs. So what's going to happen if you trace it is this didn't check out, this won't check out, this checks out, so that means that we'll go to line 9, and then after line 9 we go to at least I'm not an artsy, regardless of anything. So the point made there, which was a very good point, is that would it ever say bullseye exactly 98? No. And that's because what's happening is it checks this, and if it's greater or equal to 98, it just prints hooray, and that's it. So it won't even ever check whether exam grade is equal to 98, so we can see what's happening. So it printed hooray. Why did it print hooray? Well, I put a breakpoint here. And now it checks, is it greater or equal to 98? Well, yes, 98 is greater or equal to 98. So it'll print hooray, and then it'll skip to line 14 because it's done. It just checks one condition. If it checks out, it's done. So if we really wanted to print the bullseye, what we would do is we would rearrange it. Right? So now that would print the bullseye. And that's because it'll first check whether, and thank you again, it'll first check whether exam grade is equal to 98, and if it is equal to 98, then it'll print it, and then it's going to go here. And then if it's not exactly equal to 98, it'll still next check whether it's greater or equal to 98. So just to run through it, so 98, you'll notice that the green thing doesn't always appear. You can still press next, and we're here. So exam grade is 98. Is it equal to 98? Yes, so that prints. And now if I press next, it jumps to line 14, like so. On the other hand, if you get 99.5 something, oops, then if I run it again, So this doesn't check out, so that means it checks the next elif. So it checks is exam grade greater or equal to 98, and the answer is yes. So it'll print array. And now it'll print at least on not an args. So to summarize, the order here does matter because it checks the conditions top to bottom, and what matters is the first condition that turns out to be true. Yes?
Instead of rearranging them, you could also just remove the greater than or equal to and just remove that?
Sure. Yeah, you could do that. Yeah. So, and like arguably that would be better. Yeah. All right. So, okay, so that's that. In the lab, which is happening, I think, for some of you Wednesday and for some of you Thursday, if I'm not mistaken, will make you trace through your code. So I think it might look, well, I mean, I like it. I think it's fun, but it might look kind of tiresome. It's actually a really useful skill when you later need to debug larger programs. So we'll make you do it now. Hopefully you do it. I'm don't want to kind of like talk it down. It is actually fun, but I really do suggest that you kind of figure out how to do it now, even if it seems right now superfluous, because you can just read the code and like you know what's going on, or you think you know what's going on. It's gonna turn out to be useful later on in the course. And the habit of actually going line by line is, I think, one of the things that distinguishes people who spend like 20 hours on assignments and people who spend like 3. Because if you know that you can just go line by line and figure out what's going on, you can write the solution a lot faster. So something that characterizes both, like, you know, something like, you know, almost any ESC 194 question and almost any ESC 180 question or even assignment is that if you knew exactly what to write, if you knew exactly what to type, it would take like 3 minutes. It's not that it's very long, it's that the challenge is figuring out what to do next. And a lot of the time, and I really do suggest that if you're not in that mindset now, that you try it, and I promise you it works. The mindset is like, slow down, do things one line at a time. So in calculus, one step at a time. Don't try to run ahead of yourself. If you think through things systematically and don't try to rush, actually sometimes it works better. Sometimes, of course, you're kind of stuck and you want to run a little bit ahead because you don't exactly know where to go, and there's multiple directions in which you can go in order to solve the problem. And that's, I think, why people feel like they should just go ahead and write stuff and then think later. But usually it doesn't. Well, half the time it doesn't work. If whatever you're doing doesn't work for you, try my way. So that's that. Other questions? What's going on in Discord? Fascinating. Okay. I have no idea what that means. I don't think anyone else does either. Okay, all right. So I'll just briefly talk about physics stuff if you want to run it in Paizo, which, did they tell you to? They probably didn't tell you to run anything yet. But so basically what you need in order to run the physics code, which apparently you already have, I didn't actually know that, is to install Anaconda and to then make it so that the configuration of the Python is to Anaconda, not to whatever else. So by default, what you'll see if you install Python from scratch and Paizo from scratch, it'll tell you to install Miniconda, and actually Paizo.org is going to guide you to use Miniconda, so that should be fine. But if you already had Python pre-installed, that the situation that you might have is when you do edit shelf configuration, then you have something like this. Usually it would just be Python, and this would be like something like this. On different computers, it's going to be different. So what you want to do is you want to add another configuration, and you want to set the setting here to, for example, something like Miniconda 3.7. If Miniconda is installed, this hopefully will show up. Unfortunately, not always. It depends on the system. So you can always, if you installed Anaconda and it doesn't show up, if you know where you installed it, you can just type it in here. And the pattern should be kind of whatever, and then Miniconda and Anaconda, and then bin Python. So that's kind of the general idea. Unfortunately, some of it is not. So if you know exactly where Anaconda is installed, and if Anaconda is installed already, it's not a problem. Just write where the Python is in the Anaconda, and that's it. But you need to remember when you install Anaconda where you installed it. If you know that, just Anaconda, whatever, and then bin Python. Once you have that, what you want to do is, so you can stop the shell. So now there's no shells, and now I can start an Anaconda shell. And here I can do something like import SciPy, which is usually what doesn't happen if you don't have Anaconda. So if import SciPy works, then you're probably fine to run the physics code. All right, other questions? All right, I will see you Wednesday. Thank you. Yeah.
I had a question. What do breakpoints do?
What do breakpoints? So they stop the execution of. The program, right? So, yeah. Hello, just I'm talking here. So if I don't have this and I just do Control-E, so run the entire program, just the entire thing runs. If I put a breakpoint, then when I execute, so now I'm on line 1, so then I can create.
So it can
go
trace
next.
line by line.
That's right.
When does it end? Until the last line?
Well, I mean, so you can press continue, just continues running your program until the last line. Otherwise, if you go line by line, well, yes, the last line would be the last line. Yeah. Hi. Yeah. Well, so do you have any comments? Yeah. So on Python, for quick start, the second step in the instructions is to install Anaconda. So people sometimes skip that because they already have Python installed, so it's kind of going to work for them anyway if they just run Python. But for the physics stuff, you need to install. Sure, that would work, but also on the Python website, the second step in the quick start. Well, the name itself doesn't matter. What matters is the example. So, like this part should have Anaconda, and for that you need to have it installed. Okay.
Thank you.
Yeah, thank you. Underscore exam grade. Wait and try again. So you can try, see. Oh, I see, because it was like somewhere on the second screen. So it's just that I think you're using a second screen sometimes, and it's got that the other dialog box on the other screen.
Right.
here you were missing the underscore.
Makes more sense. Thank you so much.
Yeah.
I wasn't here Friday, so I was just coming to check some things. So, download Python. Is that just because you're
Python. So if you go to the course website, do you know where that is? No. So the course website here, and then if you go to calendar, there is a recording of everything.
Oh, amazing. Okay, I'll
Okay.
check that out. Thank
Yeah.
you.
Hi. I have Anaconda downloaded
Okay.
on my laptop,
Okay.
but when I go to run it in Paizo, it doesn't give me an option. It just gives me Paizo.
Well, so add the shell configuration. Add config. Oh, it actually does that. So can you put it down, please?
Yes.
What?
Yeah, I don't know. My computer keeps like glitching out of Paizo. I don't know why. Like I just installed it following the steps, but I don't really know why it keeps doing that. Perfect. Like, I don't really know who I'd go to fix them.
So I think so. It wants something from you. We just close this.
There's like one thing. Like even when I click run
Yeah.
here with the shortcut, it works.
Yeah.
But
So
if
I
go
think
run
it's
file-
just that for some reason Anaconda thinks. This is interesting.
Yeah, that works.
Yeah.
But if I go like to run at the top and do like run as file,
Thank you, Professor.
Yeah. So that works. So run file.
yeah, when I click the run file as script, it like glitches out too. Oh, yeah.
Yeah, so I think it's just because. So do you sometimes use a second screen or something?
Not really, no. Would that just be like my computer?
Well, I mean, some kind of interaction between Python and your computer. I've never seen something.
I
Yeah,
tried to like get rid of it.
yeah, so I mean, it's fine like this, right? So if
Okay.
it's not like full screen, then it's okay.
Okay.
I just never
that's
seen
okay.
that.
That's okay.
Yeah.
So I already have Anaconda though, right?
Yeah,
That's
yeah,
working.
so you have Anaconda, and actually, like, if it's not full screen, it's not switched. So,
Thank you so much.
Yeah.
Have a great rest of your day.
Yeah, right?
I just had a question about Anaconda. So
Okay.
I also like edited the shell configuration.
Yeah.
Then is it this one?
I mean, that seems plausible, yeah.
Okay, and then so yeah, when I use it, it like you know how yours says like in and then square brackets 1.
Yeah,
2,
so
3.
so that's, if you put it down, so that's just a checkbox. So, assuming you have it installed, which you probably do.
Yeah.
I did it for the Python and not actually the Anaconda. Okay.
Oh, thank you. And also for the debug, like debugging like this stuff,
Yeah.
it doesn't show up for me. It's just like
Well, I mean, it wouldn't because you're not running it.
okay. All right.
So, like, so breakpoint, then run, then it'll
Thank you.
be great. Yeah.
Also about Anaconda.
Yeah.
Which one exactly do I download?
I mean, graphics seems fine. Well, so M1. Do you know if you have M1?
What is that one?
So that's like an architecture for the CPU.
don't know what you have exactly.
I'm just gonna hope that I have
Yeah,
it.
yeah. Well, like if it doesn't work, you like if it's not right, just try the other one.
Okay, thanks. And what I do with Paizo?
So when you're doing so here, once you've installed Anaconda, hopefully there's going to be something on the list here.
Got it. Thank you.
Yeah.
Sir, so like when I try to run the line by line,
Okay.
but then like this page just comes up. Is that
Yes.
like one of its limitations? Or, like,
Well, it's not.
like,
It's
what
like
happened?
one of the annoyances. So this is like after the last line you clicked and that happens. So that's why I always click the continue at the last line.
Oh, okay.
Yeah. I mean, you can just close it. It's not a big deal.
Okay, so like after
Yeah.
you're done the last line, you click this.
Well, I mean, it's
so-
just that like if you don't want to see this, yeah.
Okay. All right.
Yeah.
Thank you.
Like it's not a problem to close it, right?
Okay.
Hi.
So during summer was the art studio, the
Yeah.
tracing was kind of different.
Kinda
Like,
similar. Oh,
the
yeah.
whole
Well,
yeah.
so kind of, so like those are both kind of tracing, but here I'm putting more of an emphasis on actually doing it with a computer. Like it's still tracing, we just did it kind of by hand.
So if I understand right,
Right.
what we're supposed to do is select the dot, the red dot on the first line of code, and then we generate the kind of loop looking arrow, and then we keep going until the last line when it's gonna give us like the print thing.
Well, I mean, like, so for now, that's what we saw. So, like, we'll see used for that when we're trying to debug larger programs, right? For now, what you described is the process of tracing the entire thing.
In the lab, that's how it's gonna work, or
Well, in lab one, I'll ask you to do that and show to the TA that you managed to do it. Yeah.
okay, thank you.
Yeah.
Okay. What is Anaconda? Is it like a library that we're supposed to download?
Uh,
Because I've been
so-
using VS Code.
No,
just
that's
to
that's
Paizo.
that's separate. So Anaconda is like a collection of Python libraries, including stuff that allows you to kind of plot figures, stuff like that.
Right, and do we need that for this
No.
course?
Like a little bit, but like not now. So for physics, though, if you want to run the physics code, you need that.
Okay.
Or, I mean, it might be that you have it installed, but
Maybe because I've been using
right.
VS Code, so I only
Right.
had Python installed.
well, so like by default, unless like you specifically did anything to install it, it's not installed.
Right.
But yeah, maybe you did. I don't know.
Okay.
Yeah.
Thank you.
Hi.
I was able to get rid
Yeah.
of like the
Yeah.
Dipsy code.
Okay.
The problem is just this one. It's saying that like the fifth, and I added them to the same file and everything.
Right. So to run, so what you want to do is run a script. Oops. Yeah, that is working.
Oh, just run a script, like run everything.
No, well, so it's more that Paizo by default. So you're right. Like you put them in the same folder. That's good. Paizo doesn't set the internal folder for Paizo to the location of the file.
Oh,
So
okay.
run a script. The first thing it does is it looks up the location of the file that you're running, and it sets the internal Paizo home location to that location so that it can see the other file.
Oh, okay, all right. Thank you very much.
Yeah, sure.
You have a great day.
Bye. You too.